Does the foliation picture, am I right then in thinking that it will enter quantum mechanics again because of non-locality, and that we want there to be this absolute simultaneity relation between two entangled particles?
It's not the entanglement. It's that what Bell's theorem shows, and this is really in some sense independent of quantum mechanics because it's just stuff in the lab. Bell proves a theorem that covers all causally local theories. Okay, all of them. Quantum, any theory. It doesn't matter how it's built. If essentially all the causes of an event lie in or on its past light cone, which is essentially the definition of causally local, then Bell shows that there are certain correlations that cannot be predicted or explained by a theory for events done in separate labs far away from each other and at about the same time, technically at space-like separation. That's the theorem, right? So the theorem says, if you have a causally local theory, it cannot predict such and such. Yeah. Quantum mechanics predicts the thing that can't be predicted. But then more importantly, essentially, you go into the lab and check, and Bell's inequality is violated. So then we say, all right, that says the world contains some causal non-locality. And now the question is, how do I implement that in a clear, precise way into my physics? The easiest way to do it, I'm not saying the only possible way to do it, but by far the easiest way to do it is to add a foliation, to appeal to a foliation in implementing that non-locality. You can really tie yourself in knots or try lots of tricks to do something else, but it makes your life 1,000,000% easier in trying to just write down a clear theory that can make these predictions, to have a foliation to play with. And then you can say, look, it's no longer that all the causes have to lie in or on the past light cone of a theory of an event, but all the causes lie to the past of it, right? You can still have that, as it were, causes always precede their effects. All the causes of an event lie to the past, where I've got this foliation. So I've sliced the space-time. I've got this event. I have this slice through it. Then everything to the past, that's potentially could have an influence on it, right? Then you can write down the theory. Then you have no problems. Now, people got so used to not liking the foliation because of relativity that they recoil from it, right? They have this gag reflex. If you say, I'm going to introduce a foliation. To me, this makes no logical sense, because special relativity was developed thinking of Maxwellian electrodynamics. That's a causally local theory. General relativity was developed to have a theory that could replicate Newtonian gravity, which, as it was implemented, is a causally local theory. Neither of those theories could violate Bell's inequality. So, of course, neither of those theories needed this foliation. They didn't need to account for the phenomena that we get out of, quantum mechanics, this violation of Bell's inequality. Once you have that kind of phenomenon, you might say, well, gee, I need to do something, right? I mean, something's happening that is not easy to account for. Why would it be easy? I mean, Einstein was smart, but he wasn't that smart, right? I mean, he couldn't have said, oh, I understand that in 30 years, or in 70 years, somebody's going to do an experiment that's going to violate this inequality that I don't know anything about. And in order to accommodate that, I better put a foliation back in, right? So, he reacted quite reasonably to the problems he had before him, but they just didn't include violations of Bell's inequality.
Well, maybe I would just add on the foliation, just that, it's, I think, an active, an interesting, open question about whether other theories also require foliation. So whether quantum gravity ends up needing one, or even general relativity. So the theory simplifies an awful lot if you do pick up foliation, and you can explain things so nice. A bunch of issues would go away in general relativity if you did have a foliation. So, for instance, like energy is not conserved in general relativity, which then makes explaining gravitational waves and that kind of odd. If you picked a foliation, a lot of those issues would go away. So it might turn out to be useful. So if I'd hate for it. I mean, I don't get to pick what kind of reality I live in, but it'd be unfortunate if the only sign of a preferred foliation was the Bell non-locality. If a foliation could be put to work in some other way, that would be really, it'd be extra reason to posit it, I guess.